Bismillahirrahmanirrahim. As you know that force is an agent which can stop a body or which can move a body which is already at rest. Force can also change the direction of the body. Force can also move a body faster, or force can also slow down a body, or force can also change the direction of the body. These all things force can do. Or simply we can say that force can produce an acceleration in a body, because slowing down a body or moving a body faster or changing the direction of the body, these all things basically come within the ambit of acceleration produced by a force. Another thing the force can do is to change the shape of the force. For example, if I have this piece of paper, by the application of the force I can change the shape of the paper. Now these were the effects which force can do. There is another very important effect that force can do, that is called the moment of force. This moment of force basically is called the turning effect of force about a pivot. Pivot is a fixed point. For example, if I have this scissor, this is the pivot of the scissor. The scissors can move about this fixed position. I apply the force and scissor can move about this fixed point, which is called pivot, or the axis of rotation. From the daily life you can have the example of the steering wheel of the car. If you are moving the steering wheel of the car, you can turn the car in the right direction or left direction. That steering wheel is fixed at a point, so you can move it right or left. In the same way, you might have observed for turning for untightening a nut, you use the spanner. So the nut is at a fixed point and you apply the force on the spanner to tie or untie a nut. So this is also an example of the turning effect. There is another basic example of the turning effect in the daily life, is the opening the door. For example, I am taking the example of this book instead of door. So let us suppose this is door. So to open the door, you have to apply the force to turn the door open or to turn the door close. Okay, so you are applying the force on the door. The door is at a fixed place. The door is not leaving its fixed place, it is just attached with a fixed point, which is called the pivot or the axis of rotation. About this axis of rotation, the door is moving clockwise or anti-clockwise by the application of the force, because you are applying the force and the door is turning open or turning close. The same is the case in book, that you, for opening the book, you have to apply the force, and the book, this cover of the book is turning like this by the application of the force. So these are basically the turning effects of force, that the body itself is not moving, but the body is moving about a fixed point, which is called the axis of rotation or the pivot of the body. Now let us have example of this spanner. This is a nut. I have taken the example of this nut. This is the pivot. Now to untie a nut, you have to apply a force on the spanner, or to tie a nut, you have to apply the force on the spanner. So the nut is at a fixed point and you are applying the force like this. If you are applying the force in clockwise direction, so this will be a clockwise moment. If you are applying the force in anti-clockwise direction, then it will be the anti-clockwise moment. Now let us know that how we can find out, how we can calculate the moment of a force. To calculate the moment of the force, we can apply this formula: force multiply the perpendicular distance from the line of action of the force to the pivot. Now what is line of action of force? Basically, line of action of the force is that line about which the force is being applied. Now let us have an example of the spanner again. Now the spanner is fixed at this point, because here we have nut in this portion of the spanner. Now I have to apply force from here. This finger and this handle of the spanner are making a 90-degree angle. So that is why we say that this force, this is the force, the direction of my finger in upward direction, and this is making the line of action of the force, because I am applying the force like this. This line of action of the force like this, and this handle of the spanner are making 90-degree angle with each other. So this is called the perpendicular distance from the line of action of the force. This finger is showing the line of action of the force, and this is the moment arm. Basically, this is the moment arm. Remember this name, moment arm. Line of action of force represented by this finger, because I am applying the force in this direction, and this distance till the pivot from the line of action of the force till the pivot is called the moment arm. Okay, remember this term. Well, now I have taken the example of the scissors. So here this is the pivot, and I am applying the force like this. So here we can say that you are applying a force at this point. This is the force, and this is basically is the moment arm, which I am representing by D. D is the moment arm from this till the pivot. Pivot is P for pivot, I am taking it. Okay, so this is moment arm, and this is the line of action of the force, because force is acting like this. So moment is depending upon these two things, force and the perpendicular distance from the line of action of the force till the pivot. This must be very clear to you. Okay, now let us have an example. Before example, you must be aware that the unit of moment is Newton meter, not Newton per meter. It is Newton meter because force and distance are multiplying with each other. That is why it is Newton meter. Okay, now let us have another example, that there is a force of 10 Newton applied on this spanner. Say this spanner, this force is 10 Newton, and this distance, say it is 15 centimeter. This distance I am taking at 15 centimeter. Now as I told you that the unit of the moment of force is Newton meter, so this distance must be converted to meter. So 15 centimeter to meter, it is 0.15 meters. Okay, remember that you must change the unit of the distance also. Now the moment is equal to force into distance, force 10 Newton, and the distance in meter, so 1.5 Newton meter is the moment produced in the body. Well, now let us discuss the principle of moment. Principle of moment is very simple. For a body to be in equilibrium, let us consider this rod which I am taking in equilibrium. Now for a body to be in equilibrium in balanced position. Now you can see that this rod is in balanced position. So what principle of moment states that for the body to be in equilibrium, the sum of clockwise moment about the fixed point must be equal to the sum of anticlockwise moment about the same fixed point. So this finger is representing the pivot or the fixed point about which the sum of clockwise and anticlockwise moments are equal. Now let us have an example of the same. I have this rod. Here I have taken forces F1, F2, F3 and F4. Force F1 is have the distance d1 from the pivot, and F2 has the distance d2 from the pivot. Remember one very important thing, that whatever the force you are taking, whether F1 or F2, F3 or F4, you have to take its distance from the pivot. Each force distance must be calculated from the pivot, it must be measured from the pivot. So if this is F1, I am measuring the distance from pivot d1. If it is F2, I am measuring its distance from the pivot d2. So F1 into d1, F1 into d1, F2 into d2, and then we have to sum it up, the sum of clockwise moment. These are the clockwise moment. Now F3 is in anti-clockwise direction, so its distance is d3, so F3 into d3. There is another anti-clockwise direction force which is F4, its distance is F4, F4 into d4. Now by adding these two on both the sides, we can say that the principle of moment, the sum of clockwise moment must be equal to the sum of anti-clockwise moment for a body to be in equilibrium. Remember this, for a body to be in equilibrium, it is very important to say. Okay. Now if you have single force on both sides, you can also solve the numericals whether you have single forces on both sides or you have more than one force on both sides. The same formula will be applied. Okay. Let us have an example of a body which is balanced here on a wedge at P, F1 is the force which is in the clockwise direction. Its distance from the pivot is 20 centimeter. F2 another force, its distance from the pivot is 12 centimeter. We have to find out F2. Now again we can apply the formula F1 into D1, F1 into D1 which is 20 centimeter, F2 into D2 which is 12 centimeter. By applying the forces and the distances we can find out this force F2. Now here one basic thing must be remembered, that in the previous case, in the case of the moment, I told you that the unit of the moment of the force is Newton meter, but here you can see that I am taking the unit of distance in centimeter. So here when you are applying the principle of moment, so it is immaterial that whether you are using centimeter or meters, because on both the side this centimeter or meter will cancel each other. But one major thing must be remembered, that if you are using centimeter to one side, the other side must also be centimeter. If you are using meter to one side, the other side must also be meter while applying the principle of moment. Okay, I think so now it is clear. Now by applying the values in the formula, you can get that F2 is equal to 25 Newton. This is the force F2. So by applying F2 is equal to 25 Newton, we can balance this rod on a wedge at these given distances. I hope you have understood. If you have any question, you can ask anytime.